Okay, I want to talk a little bit about your calculator just for a little bit. We're going to talk about the relationship between the sine, cosine, and tangent of an angle and how it works out on your calculator here. Just a quick review. I want you to remember that the sine, cosine, and tangent are all simply related to a right triangle. It has to be a right angle in here, which is 90 degrees. The side opposite from that right angle is the hypotenuse. If this is my angle, and my angle, I'm going to use the Greek letter theta, opposite theta is the opposite side, and along the bottom of theta here is the adjacent side. And basically the sine of theta, very simply, it's a fraction. It's the length of the opposite side divided by the length of the hypotenuse. That's all there is to it. The cosine of theta is the adjacent side divided by the hypotenuse. And the tangent of theta is the opposite side divided by the adjacent side. Just three fractions. That's all there is to it. Now, most of the time they're expressed in decimals. You can use fractions, but like I said, most of the time they're given in decimals. Okay, so how does that relate to my calculator? Well, my calculator very simply has three buttons here: sine, cosine, and tangent. So if I want the sine of 45, let's take the sine of 30. Let's take the sine of 30 and close the parentheses and push enter. Now I know that the sine of 30 isn't a negative 0.9. I know that. And the problem is that there's two ways to measure this angle. You can measure it in something called radians, or you can measure it in degrees. Now what we have to do is we have to make sure that our calculators are set to degrees. You click on mode and then cursor down with your arrow keys over to degrees and push enter. Now you'll notice that the degrees is highlighted, and that's what we want. So we're going to use this second quit right here. You'll use that quite frequently when you want to get out of something. Second quit, and we're back to this thing right here. So let's take a look at sine of 30. The sine of 30, close the parentheses and push enter, and it simply tells me that the sine of 30 is 0.5. Now, just as an example, I'm going to draw another triangle on here. Very good. Okay, so this is my angle theta in here. Here is the angle that I said, and I said that that was 30 degrees. Now, if the sine of 30 is a half, which is what we said, that means whatever this is, if this is 4, this has to be twice that size, because the sine of 30 is the opposite divided by the hypotenuse. And so if the opposite's 4, the hypotenuse has to be 8 in order to give me 1/2 or 0.5. That's the concept. So let's look at another example here. What if I said I want the cosine of, say, 60? Now, I don't think it's going to come out even, but we'll try it and see. Oh, cool. The cosine of 60. Well, let me draw another little triangle here and show you what I mean. That if I have an angle, a triangle rather, that comes down like this, and this angle is 60 degrees. And again, if this is 10, this has to be half of it. Why? Because we said that the cosine of 60 is 0.5. Well, in order to get 0.5, that ratio between the adjacent and the hypotenuse, 5 divided by 10, gives me the 1/2, which is 0.5. Now, the example that I used here, you have to remember that this angle is 30 degrees up here. This angle is twice that size. That's 60. It's not the same triangle. Well, it is. Because that's 30. Now, the side opposite that 30 is 5. The side opposite that 30 was 5, and the hypotenuse is 10. Well, guess what? We end up with the sine of 30 is 0.5. It's simply the ratio of the sides of the triangle with the hypotenuse or the tangent. Now, I want you to look at the cosine of 30. What would that be? Well, it's some number divided by 8. I know the bottom number is 8, but I don't know what this top number is. Well, that's kind of strange. Let's take a look and see what we come up with here. What do I want? I want the cosine of 30. My bet is that I'm not going to get a nice even number, but we'll see. Oh, nope, I don't. I get 0.866060254 or whatever it happens to be. The bottom line is the cosine of 30 is a real strange looking number. It's 0.866. Okay? So then I know that whatever this number is up here on top divided by 8 is 0.866. If I multiply this 8 times 0.866, I will find out what this value is right here. Well, let's use my calculator and see what I can come up with here. What did I say? 8 times 0.866. And I get 6.928. So then this side over here is about 6.9, whatever that happens to be, whatever this calculation happens to be. Now there's an easier way to look at it. Okay? I can solve this in a couple of different ways. But this is principally the way we want to do it. I know that the the adjacent by the hypotenuse is my sine. If I know the sine, I can simply take the sine times the hypotenuse and I'll get that adjacent number. That's the concept that we're trying to get across. If I ask for the tangent of 30 degrees, what's the tangent of 30 degrees? Well, it's 0.5577. Well, if I take that opposite divided by the adjacent, if I take 4 and divide it by 6.9, let's see what I end up with. 5.7. See, we're real close. Now, the reason we're close and not exact is I rounded this off. If you remember, that was 8660254. I just rounded off to 866. So I got close. 0.57 is pretty close. The opposite divided by the adjacent is the tangent. Okay, now let's try something else. Let's suppose now that I have my triangle, and let's get a triangle up here. And let's suppose that this is my angle theta. I don't know what it is. But suppose that I know that this is 7 and this is 14. Okay, and I don't know what this is right here. But I do know that the sine of theta is the opposite divided by the hypotenuse. Oh, so I know that the sine of theta is 0.5. That's a half. Well, what I want to know is, what I know is that theta is the angle whose sine is 0.5. Well, again, your calculator has a nice, neat little function here that I can use the second function, second sine. If I do second sine, I get this little strange thing. I get sine inverse. Well, the sine inverse means the angle whose theta is the angle whose sine is 0.5. That sine inverse thing right here means the angle whose sine is 5. So let's try it and see. I'm saying that the sine here inverse of what? 0.5. 0.5. The angle whose sine is 0.5 is 30. That's exactly what we calculated over here earlier. The sine of 30 is 0.5. The angle whose sine is 30, the angle whose sine is 0.5 is 30. That's the concept. The angle whose sine is, what was it, 0.866025, I think is what it was. Ought to be real close to 60. Well, that's pretty close to 60, 59.9. So this function here, sine inverse, gives you the angle, if you know the sine, and the other one, just the plain sine, gives you the sine of the angle. Same thing with the cosine and the cotangent. If I know the tangent, I can get the inverse tangent. Let's take a look at my angles over here. What do we have? Well, we knew this was 0.866. This was 6.94. Okay, so let's just take this angle right here. Let's take this example right here. I know that the tangent of theta is going to be approximately 4 divided by 6.9. That's what I know. Okay, let's see how that works. Now you already know the angle. You know the angle should come out close to 30 degrees. So let's see what happens. I'm saying that the angle whose tangent is, and I can do the calculation here, 4 divided by 6.9. I don't have to do the calculation outside. I can do it here, and I close the parentheses, and we know it should be close to 30. Well, that's pretty close to 30. All right, so do you have the idea now that we can look at sine, cosine, and tangent using our calculator? The most important thing for you folks is make sure that under mode that your degrees is lit up. You don't want radians. We can talk about radians a little later, maybe if we get some time. I don't want to mess with it. I want to use degrees only. Alright, if you have questions about your calculator, don't hesitate to give me a holler. And we'll call it quits for tonight.